All right, well, let me try to illustrate this notion of a compound inequality where you're having a whole bunch of inequalities that you want to be satisfied at once with a couple more examples. Suppose I want you to find all the x's that satisfy the following. 1 minus 2x is less than 0, or 6 plus 3x is less than 0. So what's the solution set? What are all the x's that will satisfy this? Remember what an or means. Or means either x satisfies one or the other. The x doesn't have to satisfy both at the same time. And so we're looking for here a union. So when you think of or, you should think of union. So how do you do this? Well, what I'm going to do is I'm going to solve this inequality for x, and then I'll solve this inequality for x, and I'll look on a number line and see what the solution is. So to solve this, let me first look at this. So that requires a little bit of work. What am I going to do? I want to isolate the x. So I'm going to subtract the 1 on both sides and bring this minus 1 over. And so I'd see minus 2x is less than minus 1. And then I'll divide both sides by negative 2. But remember, when you multiply or divide by a negative, the sign flips. So the moment I do that, we get a flip in the sign. And so now I see that x is in fact now greater, and a negative divided by a negative is positive, greater than a half. So there's the solution to the first inequality. X is bigger than a half. Okay, what's the solution to the second inequality? Well, let me now solve this. So I'm going to sort of come out here and do a little teeny bit of work and see what happens. What I see here is, if I bring the 6 over by subtracting 6 from both sides, negative 6, I'd see 3x is less than negative 6. And now I divide both sides by 3. Do I flip the sign? Absolutely not, because 3 is positive. I only flip when I multiply or divide by a negative number. So in this case, I see that x is still less than, and minus 6 divided by 3 is negative 2. And remember, the conjunction is or. So now I see what my answer is. It's either x is greater than a half or x is less than negative 2. So let's write that out on a number line. Again, I only put in the key players. You might want to mark all in the points in fact. In fact, if you want, I can do that too. Would you like me to do that? So here's, let's say, 0. Here's 1. Here's 2. Here's minus 1. Here's minus 2. I just don't like cluttering things up. What do we have, though? The players here are minus 2 and a half. So I'm actually going to write in the half since that's so special. We're going to talk about that a lot. OK, so what do the graphs of these things look like? X is larger than a half. That means that I look at all the points to the right of a half. And I don't include a half. I have no equal sign there. So I put an open parentheses pointing this out like this. So there's a solution to that. What's the solution to x is less than negative 2? Well, I don't include negative 2, but I include all points to the left. So where's the solution to this or that? Well, I take the union. So what I do is, if you have this graph drawn, you can sort of read off the answer. I go from negative infinity to negative 2, but I don't include negative 2. See how I just copied that down from the picture here? The same thing here. I go from 1/2 with an open parentheses out to infinity, and we never have a closed parentheses on infinity because infinity is not a number. So we always have open parentheses around the infinities. And since I'm one or the other, I denote that by putting a union in, which means as long as you're in one or the other, I'm happy. Any of those things will be a solution. For example, if you pick something like negative 3, is negative 3 in here? Well, let's see. I'm asking, is negative 3 greater than a half, or is negative 3 less than minus 2? Well, negative 3 is not greater than a half. That's wrong. But notice that negative 3 is less than negative 2. So in fact, this whole thing is OK, because at least one of them is satisfied. What about 0, though? Is 0 bigger than a half, or is 0 less than negative 2? Well, it turns out the answer is no. 0 is not bigger than a half. And 0 is not less than negative 2. So 0 is not a solution to this because it doesn't satisfy either one of them. So or you put everything together. OK, let me try one last one. Because sometimes I can put a compound inequality together in one huge multiplex inequality. It's sort of like the new kind of movie theaters where you can see like 1,000 things at once. This is sort of like a multiplex kind of thing. this inequality actually means something. It means that I have two inequalities going on in the background. Let me show you what those two inequalities are. Whenever you see an inequality like this, first of all, what that means is 0 is less than or equal to 2x plus 6, and also 2x plus 6 is less than 18. So in fact, this translates into the following. 0 less than or equal to 2x plus 6, and 2x plus 6 is less than 18. So whenever you see this sort of compound inequality on one line, it really is an invisible and problem, This and at the same time that. The really neat thing about writing it this way is that solving this actually allows you to solve both inequalities at the same time. Just treat this thing as sort of one huge algebraic string. Whatever you do, though, don't think of one side, think of three sides. So whatever you do to one side, you do to the other sides. So, for example, if I want to solve for x, the first thing I would do is subtract 6. But I subtract 6 from everything. So I subtract 6 from here. It's like a balance scale with three arms. And now if I combined, I see negative 6. And I have the same inequality, less than or equal to 2x, because this cancels, and now less than, and then 18 minus 6 is 12. Do you see how I'm performing the arithmetic, but I'm doing all the steps sort of at once? Very carefully, the inequalities stay the same as they were before, but I can do arithmetic to all of them at once, and the balance of power stays intact. What would I do now? Well, now I'm going to want to get rid of that multiplicative factor of 2 by dividing by 2, but I divide everything, therefore, by 2 to keep everything the same and balanced. Will my signs flip? No, because 2 is positive. But if 2 were negative, then both of these signs would actually flip. But since, in fact, 2 is positive, everything stays as is. I see negative 6 divided by 2 is minus 3, less than or equal to x, which in turn is less than 6. So there's the solution. There's the answer. What does it look like graphically? Well, graphically it looks like this. I have negative 3, and then all the way out to 6. And what does this say? It says x is in between these two regions. So in fact, the solution is really everything in between. Things that are bigger than minus 3 but smaller than 6. What about the endpoints? Do I include 6? No, I don't include 6 because there's no equal sign here. So I put a open parentheses. Do I include the minus 3? Absolutely, because there's an allowable equal sign there. So in fact, I could write this answer as, in interval notation, as minus 3 with a bracket, 6 with a parentheses. These two statements are identical. This statement and this statement are the same. This is interval notation. This is inequality notation. And notice, by the way, this really was an intersection. Because if I just look at this piece right there, you see that piece right there? So minus 3 is less than or equal to x. What that means is that's this region right here. Minus 3 is less than or equal to x. So x is all this stuff up here. And x is less than 6. That's this region right here. And since I put them together with that invisible and, I look for their intersection. And notice the intersection is exactly the orange that I put in there. So you can see that just by using these inequalities at once, it gives you the answer immediately, rather than doing sort of one solution, the other solution, and seeing where they overlap. This gives it to you automatically in the orange, which is pretty cool. Okay, we'll try some of these on your own and get in the habit of working with these inequalities where you have more than one inequality in one line. Multiplex inequalities. Welcome to the 21st century.